have the number of electrons, the protons in the nucleus. This newly charged up atom, ion is its name.
Welcome back. In the last video we used the physical properties to classify things as either metals, non-metals or semi-metals. We're going to do in this video become the next dot point, which says process information from secondary sources and use the periodic table to present information about the classification of elements as metals, non-metals and semi-metals. That's our task number 1. And solid, liquids and gases at 25 degrees Celsius and normal atmospheric pressure. That's task number 2. And we're going to cover this dot point first and then we'll cover the second dot point later, which is an experiment you'll do in class. So for the first one, you need to be able to classify things as metals, non-metals and semi-metals. And the easiest way to look at it, and use a periodic table to do that, the easiest way to do that is we start with here, boron. What we're going to do first is look at the semi-metals. These are all semi-metals. Boron, silicon, germanium, still one arsenic. We have these ones here, which I'm covering at the moment, are all our semi-metal. So this part, it's almost like a staircase. The ones here that I'm shading are all our semi-metals. So red is for semi-metals. Then what we have to our right, so all the ones to our right are non-metals. So anything that is not in the staircase and that goes to the right is a non-metal. But the vast majority of the ones that go to the left are our metals, except for one exception. And the exception is hydrogen gas. This is still a non-metal. So first part is classify them. We've got here, these are our semi-metals. Then to the right of that is our non-metals. And to the left of that are the metals, with the exception of hydrogen, which is a non-metal. The second part was establish which ones are liquid, solid, and gas at 25 degrees Celsius and atmospheric pressure. And the reason why we use our specific values is because that's room temperature. So which of them have that state of matter at room temperature. And this table actually nicely looks at it. So the green ones are solid, liquids are blue, and the gas ones are the green ones. And what we can see is most of our metals, we said that these ones here are all metals. Metals are, the vast majority of them are solid. There's one exception, solid. One exception, which is mercury. Mercury is liquid. So all our metals except for mercury are liquid, solid, and mercury is liquid. All of our semi-metals are all solid, all green. And most of our non-metals are either solid, so carbon, phosphorus, sulfur, or they're gaseous, so nitrogen, oxygen, fluorine, and we have bromine, which is liquid, and obviously hydrogen gas on the other side is also gaseous. So more than half are gas for non-metals. We have some of them are solids, and one of them is a liquid. And that makes sense because we said that some of the properties for non-metals is they have a lower melting and boiling point. A lower melting and boiling point, which means is they're going to be found more as gas in the actual environment itself. And nitrogen, oxygen, fluorine, these are all gases. Whereas they have high melting points and boiling points for actual solids, especially the metal kind. So most of our metals are generally solid. And most of our semi-metals, they often have an even higher melting and boiling point, so they're also solid as well. Now this was the first part. We need to be able to tell, okay, which are the non-metals, semi-metals, and metals on our periodic table, and which are solid, liquid, and gas. And then the second part was experiment you've done in class, or will be doing in class. It says plan and perform an investigation to examine some physical properties, including malleability, hardness, and electrical conductivity, and to present information about the classification of elements as metals, non-metals, or semi-metals. Right, so what you've done, you would have had in your class, or what you will be having, is you will have quite a few elements. It says elements, so we shouldn't be using compounds. For example, water would not be good to use. And the reason why is water is actually a compound, it's not an element. But you're going to have some of your pure substances, your pure elements, such as zinc, magnesium, iron, copper, lead, tin, obviously, and aluminium. These are obviously most of our metals. Sulfur, phosphorus, iodine, and graphite. These are quite a few of them are non-metals. And what you're going to do is you're going to actually test their physical properties to identify them as either metals, non-metals, or semi-metals. And there's three things that it says we definitely need to do. We're going to have to check the malleability, which means how easy are they to make them into sheets, their hardness, so their strength, and the electrical conductivity. These are something you have to do, but we also can check other things. So for example, you might check the appearance. And why would we do that? Remember, check the appearance is useful because if it's dull, that means it's more likely to be a non-metal. If it's shiny or lustrous, that means it's more likely to be a metal. And if it's in between, it's probably going to be a semi-metal. So first, you can just look at all the different actual elements you're going to be given and observe them and note down the color. So you're going to note down the color and the appearance, color and appearance, because that's the physical appearance. And this physical appearance can be used to determine if it's a non-metal or semi-metal or metal itself. Then it says we need to also check the electrical conductivity. And how can you do that? What you might do in class is you might make a circuit. So this is your battery or anything else. You connect that wires to a lamp and then place in parts, so place them in a circuit. So whatever you're testing, you're going to put in a circuit. In this case, I have wood here, but you can replace the wood with, for example, zinc or sulfur, whatever you're checking. What you're going to do is you're going to see if you connect it all together and it actually makes this lamp go on. So if this is on, that means the whole circuit is on. If it's off, that means the circuit's not working. And if you have a metal, because the metals tend to be good conductors of electricity, if you have a metal in this place, what that's going to mean is the actual lamp will be on because metals conduct electricity quite well. Whereas if we have a non-metal in this place, so for example, if you put phosphorus or iodine there, because non-metals are bad conductors, you're going to see that lamp stay off. So that's also something you're going to do. You're going to test the electrical conductivity using this kind of setup. You're also going to check the density. So remember what I said about density. Density, we have low density, means it's probably going to be an actual non-metal. Whereas if it has a higher density, it might be either a semi-metal or a metal. And the metals tend to have the highest density. So by checking that, this physical property of density, we can also determine or use more evidence to determine if it's a metal or non-metal or a semi-metal. So what you might have, for some of the metals, you might have cubic centimeters of the metal. And that's good because this allows us to actually measure the volume. Cubic centimeters allow us to measure the volume. So if you have cubes of them, then all you have to do is you have to measure the mass and then use this formula to get our density. So the density itself is mass divided by the volume. So for example, if your mass is 5 grams and your volume, you have 1 centimeter of that cube, then your density is 5 grams per centimeter cubed. So that's one way that we can figure out the density. But that would be easy for some of them. Maybe for your iron or for your magnesium, you might have these cubes given. But for other ones, you have irregular shapes. So you don't have the cubes, you might have random shapes. So you can't use that because you don't have the volume given. You have to find out the volume. So there's 2 steps if you have the volume not given. First, you measure the mass, like we did the first time. The second time is you place the actual shape into water and you measure displacement. What I mean by that is this isn't before you put anything in. Now you put the actual shape inside. What happens is you can see this water has gone up, and this water is the same as our volume. So you would just read the actual increase and determine that that's your volume. Once you've done that, you would just place it all back into the actual formula and figure out its density. Things with high density might be a metal, low density might be a non-metal. And then you should also check, as it says, check the malleability and the hardness. For the hardness, it's quite easy because hardness is the toughness. You can use a hammer and just hammer away. So just hammer on the actual element. If it breaks, that means it's brittle, and that would mean so brittle substances are often non-metals. Whereas if it doesn't break, it's a very tough, very strong one. And that means it's often a metal. And for the malleability, so that's how likely it is to make something into sheets. So for example, aluminium sheets. And it's harder to actually do that as an investigation, as a prac. So what you might have to do is you have to do some research on the internet to see if you can find, zinc sheets, magnesium sheets, if they exist. So if you can find these different elements in sheets, And what you would find is you'd find the metals that you can find in sheet versions, whereas something like iodine or phosphorus or sulfur, which are nonmetals, you would not be able to find them as sheets. So high malleability for metals and low malleability for nonmetals. But yeah, for this experiment, you would have just did what we did earlier, discussed in the last video, where we're just talking about physical properties. But what you would have actually done is you would have just observed them yourself in class to see if you can classify things as nonmetals and metals. But yeah, just to have an idea of why you check the appearance, why you check the electrical conductivity, why you check for density, and why you check for malleability and hardness, how those properties relate to actual substances. I hope that was useful.
Thank you for watching.